In this session, I would like to introduce you MAC layer. Okay, so multiple access control. To understand multiple access control, first you should understand the requirement. Let's say you have some computers A, B, C, D or any devices and you want to connect them. Already I told you we can connect them using mesh topology, right? Connect everything to everything. So that is a costly affair. That's why what we do, we try to connect them to a common medium, right? Like this. So imagine this model where you have only one medium and everything is connected to that medium. And whenever example system A wants to communicate with B, then somehow this system A should acquire this channel or medium and it should say that I am now sending the data, no one should send. So in that way it should declare it, after that it should send, correct? We will see how the things will work. First of all, we'll see the high level idea. Similarly, anyone in this model wants to send the data, they should explicitly declare that so I am acquiring the channel. See, we will see how to acquire the channel. After that they should send the data. What if multiple systems at a time they send in a common medium? Then what happens is one signal will collide with another signal, that is called collision. We should avoid it. That is a major problem with shared medium, right? When there is a dedicated medium, that is called point to point link. When you have a point to point link between two systems, there is no such case, right? But when multiple systems are connected to one common medium, you get such kind of problems. To avoid that problem, so far we have not seen, right? Just we have seen framing, error control, flow control, which are part of data link layer. And I want to say that this access control also, here we can say that here who should send the data at this moment. That is nothing but access control. Usually the access control problem arises when there is a shared medium, right? Now let's talk about shared medium. Whenever there is a shared medium, then we have to control the access. That for that you need some separate software, right? It's a functionality. So to implement that functionality, usually we do that in a data link layer. Okay, so finally you realize that data link layer has another job, that is MAC, otherwise multiple access control. So far we have seen framing, error control, flow control, they are all part of logical link control. Okay, so we say that is LLC. Now we are going to learn some extra things, right? Extra software, otherwise extra protocols. They are part of MAC. MAC means multiple access control. In that way, data link layer can be divided into two parts. So logical link control is one unit, MAC is another unit. Now I can say one thing. Example, let's say there is a connection like this, point to point connection between some two computers A comma B. Then there is no shared medium. Then when there is no shared medium, then this MAC layer is unnecessary, correct? So I can say that if this is your data link layer for these two computers, in that, let's say this is data link layer, what I want to say is what will be the structure of the data link layer when there is no common medium? Simple. So you will see LLC, because we should do framing, error control, everything. Now the remaining thing is MAC. This will be empty. That means we don't implement here any such software. That's it, quite obvious. Really we implement MAC only when there is a shared medium. That's why for this kind of computers, like the computers which are connected without shared medium, they will not need any MAC layer. Okay, so MAC layer is only required for shared mediums. You remember that. Now, so before going to this MAC protocols, that means we need protocols to access the medium, right? When there is a shared medium, there are so many techniques to do that. We will see that. Before that, I would like to classify our networks into three parts. Generally, whenever you have a network, you know what is network, right? Set of computers which are interconnected. So we can connect set of computers in three ways. One is LAN, second one WAN, third one is MAN. Just it is a classification. Okay, so how people classified the networks, existing networks, we will see. Some of the networks people said LAN, to some of the networks people said WAN, and some of the networks people said MAN. We'll see what kind of networks generally are considered as LAN and MAN and WAN. First of all, we start with a network. Example, let's say you have a network, let's say you have a college. In college, let's say you have some computers which you connected. I don't know how you connected. So whatever the way you connect, I don't know, but generally, so that all the computers, if you see the distance, they are 1 kilometer apart. Okay, that is what the geographical hierarchy, otherwise model. So such kind of connections are network. Let's say see this network, which is your college network. where systems are connected and the distance between them is at most 1 kilometer or 2 kilometers, right? That means I want to say that the distance is very small. Then such networks are called local area networks. That's it. It's a simple classification. Okay. Now, sometimes you will see in the internet some of the networks which will have longer distances like this. Example, let's say there will be one connecting device which is in America and one is in India, one is in Sri Lanka, one is in Pakistan, in that way. So when there are multiple computers which are separated with thousands of kilometers, and still you want to connect them, how you connect, I don't know. Like there are a lot of such architectures. So now we are just classifying. So when you have such kind of computing devices and you want to connect them, but they are 1000 kilometers, 2000 kilometers in distance, then to connect them, whatever the protocols you use, whatever the architecture you use, that entire thing is called such kind of networks are called wide area networks. It's a classification. By seeing the network, generally I can say whether it is a local area network, otherwise wide area network. Only one thing, usually you ask yourself this question, I mean the computers which are generally connected are very in shorter distance, that means all the computers are only spanning over 1 or 2 kilometers, then I can say it is LAN. If your computers, whatever it is, they are separated over thousands of kilometers, that is called WAN. That's it. Usually colleges and institutions, small organizations use this LAN kind of networks, right? Now, so this, who uses this WAN, I will tell you. Actually, so why you are able to use internet? What is internet? I will tell you internet in a clear way again and again. At this moment, just I introduce what is internet. Internet is nothing but there are a lot of small computer networks. Imagine, let's say this is your college, okay, some X. There is another organization Y, Z. In that way, there are a lot of organizations, and each organization has some computers, but they are distributed. Let's say this is India, this is, let's say, America, same story, Sri Lanka and Pakistan. Now, to form internet, that means to have the data exchange between these computer, this computer, this computer, these computers, then what people did is they connected these networks using routers. Okay, so we will see what is router, everything. Let's say router is also one connecting device at this moment. Okay, so using the routers, let's say all these networks got connected, which forms internet. I can say that internet is nothing but network of networks. When you have this kind of internet, if you see here, these devices, right, so they have to communicate to send the data properly, right? So finally these routers also will be somehow logically interconnected to connect this kind of routers, because you need some connecting devices which connects one network in India, one network in America, right? So such kind of devices, if you want to connect, that means you want to form finally a network of routers, let's say, so that you can have internet. So to connect this kind of devices which are having hundreds of kilometers distance between them, then this kind of local area network protocols will not work. That's why especially they are called wide area network. Generally they require different architecture, different protocols. Okay, they are called WAN protocols. Okay, similarly LAN requires some different category of protocols for access of communication or anything. So that is called local area network protocols. So finally you will realize slowly that LAN protocols are different and WAN protocols are different. Okay, so now what is LAN and WAN? If you want to know within one line, it is very simple. Generally, when computers are connected with very less distance, that means they are distributed over 1 or 2 kilometers, that is called LAN. And when you want to have a network with computers which are geographically distributed in longer distances, okay, they have thousands of kilometers distance, then such kind of network is first of all called wide area network. How to connect them? That means to have such kind of network, what kind of protocols are required, what kind of architecture is required, how to send the data from one such router to another router. So all these things comes under WAN protocols. But in GATE exam we don't have any WAN protocols. That means we are not going to study, just we understand that there exist some WAN protocols. Okay, now we only focus on LAN protocols. That means we have Ethernet in syllabus. So that means Ethernet is one of the, I can say, set of protocols. Ethernet, I can say, one of the model which governs, otherwise which explains that how we can connect computers in a LAN. Computers can be connected as a LAN in so many ways. For that you need some protocols, right? We will see that. Ethernet is one of such set of protocols. We will see that. Okay. That's why we are going to study LAN in detail but not WAN. One more category is possible, that is metropolitan area network, MAN. So I will tell you what is MAN. Example, there is a college which is in, let's say, Hyderabad, and that college has two sets of computers. So one set of computers are in area number 1, another set of computers are area number 2. Okay. Now this college wants to connect all these computers to all these computers. That means it's not necessarily all to all, but finally all these computers should have a path to all these computers. That means finally they should have entire thing as a one network. For that, so what they can do is they can take one connecting device. We'll see what kind of connecting devices generally we have. Let's assume that, let's say this is a connecting device. Using that, we connect like this, and here to here we connect. Understand? In between probably you may use some other set of connecting devices, not a problem. Okay. Now like this. So finally, so what you do is, in this level, if you understand, this set of computers and this set of computers are connected by some connecting devices, so that exchange of information from here to here is possible. Such kind of networks are nothing but called metropolitan area networks. Usually metropolitan area networks are between LAN and WAN. So LAN is nothing but connecting devices within 1 kilometer or 2 kilometers distance, and metropolitan area networks are usually connecting the devices who are 50 kilometers distance apart, or some 100 to 200 kilometers apart. But wide area networks usually can span over thousands of kilometers. In that way, based on the distances, and usually we can classify them into three parts. And one more thing, so generally who maintains this kind of LANs? Generally the colleges, institutions, organizations who have some set of computers and they want to connect them, maybe because all these computers are 1-2 kilometers distance apart, then they might use LAN kind of technology. And who use WAN kind of technology? Maybe that internet service providers, because that internet service providers who are going to give us connectivity, so they have to connect devices maybe such a way that, example, let's say there is some network in America and there is one network in India. To have internet, that means to have connectivity between these two, then definitely that ISP providers really want to give the connection between them, then they may use lot of architecture, like they put cables through oceans, everything. See, from America to India, how can you have connectivity? Maybe they use satellites, they may use long cables which goes under ocean, right? Optical fibers. So using that, all these systems will be connected. Okay, usually we don't require them, but generally that internet service providers who gives us internet, so they will be finally related to this kind of WAN architectures. They have their computers which are thousands of kilometers apart. That's why they use WAN kind of protocols. The protocols required for connecting such kind of devices is out of the scope for us, of course, but that's not there in the syllabus. That's why we are not studying. Similarly, MAN protocols also not required for us. Okay, so we are especially focusing on only Ethernet. That is what our goal, because in our GATE syllabus we have Ethernet. What is Ethernet? Is Ethernet, I can say, a technology. Okay, so otherwise some set of protocols, and that protocol say how to connect your computers in a LAN. Example, you want to have a computer network, LAN network, let's say. I can say, no, now you know what is LAN, right? Let's say you have a LAN, but in LAN, to exchange the information between two computers, what kind of protocols are required? Okay, so for that, Ethernet is one of the idea. We will see that Ethernet. Okay, now let's begin with that MAC protocols. In this session, I would like to add MAC, medium access control. So we try to understand when we use medium access control. Before that, so what are the things we know? So far we were not worrying about internet and set of networks and hundreds of protocols which are existing now, correct? We know only one thing. When we have two computing devices and if you connect them somehow, then what are the things or what are the issues we have to solve, correct? So first of all, when you connect two computers through some link, let's say this is called, let's say, link. Okay, now already I told you how to connect them, everything. Now definitely To send your message, then definitely that should be converted to signals and signals to be transferred, correct? That is the duty of physical layer. Okay, so finally you understand the duty of physical layer. In this communication, physical layer is required. Second one, data link layer. What is data link layer and why it is required? Whenever you send a message from one computer to another computer, then because of this physical medium, some of the packets might be lost. That's why we have to take care of error control, right? So that's why we have some functionality. One is error control. Second one, when you send the data, what can happen when it is lost? We have to send it again. Second thing, this receiver might have a little bit small capacity, so that we should not overwhelm, otherwise we should not flood him with thousands of frames, right? That's why what we are going to do, access control. All these things we have studied, and these are all things are required between any two computer communication. Whenever you want to send a message from one frame to one computer to another computer, generally all this stuff is required. That is nothing but data link layer. Data link layer is nothing but collection of some functionality. Similarly, physical layer also contains some collection of functionality. Now, so everything is fine, then why we require something else? We will see. Example, let's say we have multiple computers, okay, and you want to connect them. So already we have seen that to connect them, so maybe you have so many ways. One is connect everything to everything through physical links like this, correct? It's costly affair. If you have 100 such computers, so connecting everything to everything will take lot of links, and it's a costly affair. So we want a cheaper model. So what is a cheaper model is generally having a shared medium. Don't try to have a separate medium for every two computers. That's why see this kind of structure. So that is the beginning point. Now slowly we are moving to connecting multiple computers, right? So to connect multiple computers, we require shared medium, right? When there is a shared medium, then along with shared medium, it gives you some problems also. We have to solve them. So what is that is, so here multiple computers are accessing a common medium, then probably what happens I will tell you. Example, let's say station A, station B, these two stations wants to send the data, okay? So at this moment at 9 o'clock in the morning, station A has some message which is nothing but a signal, okay? So that signal that A wants to transfer. For that, what this A will do? A will send that signal onto the medium. Once signal comes, it will start propagating, correct? Now at the same time at 9 o'clock 1 second, this station B wants to send the data. Then it will send on to the medium, right? At the same time you see. So from this point onwards, so two signals together will start propagating, and these two signals will merge, and you get unexpected signals or improper signals. So this is called collision. So when collision occurs, so no message will go properly. That means messages will be, I can say it's all about voltage signals, right? So two signals might become, example, there is one signal 0, another signal 1. They will become maybe a different signal called 1, and 1 will become maybe 0. I don't know, right? So what, anything can happen. So finally, as a computer science student, what you should understand is when two messages are in the medium at a time, so there is a chance of collision. Because of collision, then you may lose some of the bits in your message. So to avoid that, we should avoid the collision. How to avoid the collision? For that we need some mechanism, right? That is nothing but MAC, multiple access control. When multiple computers access at a time, we have to control it. How to control it is now the new problem we are getting, right? So we have to solve. Let's see now. Usually now we have 3 layers, right? So far we require 3 layers. One is, first of all, how to convert your message to signals. Physical layer, right? What kind of signals to be used, everything, physical layer. Now what is data link layer? So this data link layer is nothing but this high level, let's say this is network layer. Network layer is going to give you one packet, correct? That packet has to be transferred without errors, right? That was the job of data link layer. For that we did error control, right? Similarly, we realized that flow control was required and framing was required. So these 3 functionalities are part of data link layer. But now we are adding one more sometimes when you have common medium, that is MAC protocols, okay, multiple access control. So how to control the how to control the access? For that there are various techniques. Okay, now we'll study all these techniques one by one, but in GATE exam we have only one technique called Ethernet. Okay, so we will see Ethernet. Before that, before learning Ethernet, though they are not in the syllabus, I am going to teach you some various kinds of MAC protocols. Okay, yeah. Now we'll see various MAC protocols. Before that, first of all, we'll see the data link layer. So data link layer functionalities can be divided into two parts. That framing, error control and flow control is also known as logical link control. Okay, so logical link control contains that. Now MAC is nothing but especially multiple access control. For that we need some protocols, right? So in that way your data link layer can be divided into logically two parts, right? Now why this separation I will tell you. Example, let's say you have two computers which are directly connected. Okay, so that means they don't have shared medium. This is not a shared medium, this is called point to point link. When you have a point to point link between two computers, they don't require any MAC protocols, right? That's why, so they require only LLC protocols. In that way, if you have this kind of logical separation, I can say that, when two computer doesn't have this common medium, then only directly this set of protocols I run rather than this one, because the MAC is unnecessary, correct? So MAC protocols only required when you have a common shared medium, right? So in that way, that distinction is necessary. Now we will focus on these protocols. Already we have studied all these LLC protocols, isn't it? Now we will see MAC protocols. So MAC protocols are in three ways. Random access protocols. So I am just categorizing, okay. Controlled access protocols, channelization protocols. In GATE syllabus we have especially CSMA CD. Okay, that means directly we have this one in syllabus. For completeness, okay, sometimes what happens in GATE exam, though they mention only CSMA CD, but suddenly they might give some of the problems from Aloha protocol. That is one reason. So we just try to understand basics of Aloha, okay, and this CSMA CD. And we don't learn CSMA CA because it is not required. Already I told you, because that is not part of the syllabus. Since CSMA CD, which is nothing but Ethernet, so and Aloha, they have similarities. That's why. And one more thing, this CSMA CD is inspired from Aloha protocols. That's why we learn Aloha, so that understanding CSMA CD or your Ethernet is easy. Remember one thing, we have only one thing in syllabus, that is Ethernet in this entire thing. That Ethernet falls here. That is one of the random access protocol. Okay. But for completeness, I am teaching what kind of MAC protocols we have. Random access, controlled access, channelization. Simply discard, ignore them. Channelization protocols. We just learn that we have these protocols, just we remember them. But we really don't learn it, okay? So we don't learn what is reservation, what is polling scheme, what is token passing. But I will tell you the functionality. In these random access protocols, the protocols are designed such a way that any machine which has a frame, it can directly send the data. That means, of course, before that various things has to be taken care. But what is the main idea about random access control is, when any computer wants to send the data, that means the requirement for this computer to use the channel is random. Anytime any computer might require this channel. So such kind of protocols are random access control protocols. We are going to study Aloha, after that CSMA. CSMA is nothing but carrier sends multiple access. In this Aloha we don't sense the channel, but in CSMA we are going to sense the channel. We will see everything in detail. So CSMA CD is nothing but carrier sends multiple access, and this one is collision detection. So in CSMA CD we are also going to detect the collision. Now in CSMA only we focus on how to sense the carrier. Okay, that is the difference between these two protocols. Now final one is CSMA CA. Carrier sends multiple access but collision avoidance. So here we avoid the collision, okay, but again we are not going to study this CSMA CA. We are only going to study Aloha and CSMA CD. Understand? And one more thing, actually even Aloha is not required, because in the syllabus they clearly mentioned we need only Ethernet. Ethernet uses a technique called CSMA CD. That's why we have to learn only CSMA CD. But completeness purpose, I am going to teach you Aloha and CSMA CSMA CD. I can say that these three are related protocols. Okay. Now in controlled access protocols, what is controlled access protocol? In controlled access protocol, so there is a way we are going to control the computers. So now access is not random. So to control the access, that means to decide who should, first of all, who should use the channel, everything, we have some of the strategies: reservation, otherwise polling, and token passing. Okay, so there is one concept called token ring. Actually token ring uses this token passing method. Okay, but it is not there in the syllabus. We used to have that in the syllabus. Okay, at this moment what I want to say is controlled access protocols are not required for gate. Okay, that's why I don't want to discuss these protocols. Okay, now channelization protocols. In channelization protocols we have frequency division multiple access, time division multiple access, code division multiple access, and these are all not there in the syllabus. Again we have only that part, random access. Understand? So channelization protocols also we are not going to study, but we just try to understand the rough idea. What is this frequency division multiple access? Imagine this is your channel. So in frequency division multiple access, what we do is that protocol divides this channel into some fixed bandwidths. That means, example, this channel has, let's say, 10 bandwidth. Okay. Now if I divide into 5 parts, I divide the bandwidth into 5 parts. Okay, each bandwidth of size 2 MB. Okay, so 10 MB bandwidth is divided into 2 MB. That means if a computer, if it wants to send the frame with 10 Mbps bandwidth, that means within 1 second 10 MB data can be sent. But we are dividing that bandwidth into 5 parts. Now we are going to give that bandwidth to 5 computers. That means each and every computer can use only 2 MB bandwidth. So it will have a particular, you can imagine like this. So this area is for your system A, this area for system B, in that way. So your bandwidth is divided into 5 parts and each part is given to one computer. Now the disadvantage of this model is, example, this channel A doesn't want to use anything. At this moment A doesn't have anything to send, then its entire channel will be wasted. Usually in telecommunications, you have a computer and your friend is using another computer. At this moment, actually, whenever you purchase a telephone line and a computer, one telephone, then this channel is specially dedicated for you. So if you don't use your computer, telephone, then the channels cannot be used for others. So this medium is unnecessarily wasted. Okay, here also the same model, if you use here, frequency division multiple access, what happens is, at this moment your bandwidth, if you don't use your bandwidth, it will be wasted. That's why this model is not good. Now time division multiple access. In time division multiple access, again your bandwidth will be divided, but how it will be divided we will see. Based on the time it will be divided. That means this is your, let's say, whatever the bandwidth, 10 MB. Now if there are 5 computers again, then we are going to divide the time into fixed intervals. Now we are going to teach every computer that, my dear computer, so everyone has a fixed interval of time. You should know that. Okay, that is what protocol. In this protocol, every computer knows what is the allowed timing for them. Example, let's say in one typical 10 seconds. Just for imagination, we are dividing 10 seconds. We are using 10 seconds, but generally it will be smaller. So 10 seconds. In that 10 seconds, we give 2 seconds to A and next 2 seconds. That means 2 to 4 seconds to B, 4 to 6 seconds to C, D, E, in that way. 4 to 6. 6 to 8, 8 to 10. Now every computer knows that. So every computer counts the time. So whenever that computer gets the time, its own time, then they will start sending. Okay, this is called time division multiple access. In that your bandwidth is divided into times. Okay, so every time is some piece of time is dedicated for one computer. Again the limitation is, example, let's say at this moment computer A doesn't have any data in this period of time, 0 to 2 seconds. So it's wasted. Now only that computer has to use that, but computer doesn't have, let's say, any frame to send, then immediately, so it is going to waste that time, right? But at that time your B, C, D, E, everything might have data to send, but they are not able to use it because it's not their turn. Now see this one more situation. Once A's turn is over, B started sending. Now A got its data, then it has to wait for again 10 seconds of time. then only it gets again its turn, right? In that way, that's why. So there are a lot of problems with time division multiple access. It's not flexible. When you divide your bandwidth into, frequencies, otherwise time. So using the time or frequency, whatever it is, finally what is going to happen? Inefficient usage of resources, right? So that is a problem. That's why don't divide. Next, code division multiple access, also similar technique, but we don't have these things in syllabus, we don't focus on them. So rather than wasting the time, we directly go to our important protocols, which is nothing but CSMA CD. Okay, based on CSMA CD technique, your Ethernet is designed. I will tell you what is Ethernet. Before that, we learn random access protocols. Okay.